In this video, we're gonna talk about delegation pattern in Kotlin. Delegation pattern is an object-oriented design pattern to achieve the same code reuse as inheritance. The concept of this pattern is just delegating responsibilities to other objects. Delegation pattern has several benefits over inheritance, and some of them are: first, it resolves the lack of multiple inheritance. Because in Kotlin it's not possible to extend multiple classes, by using the delegation pattern we can eliminate this problem. Second, delegation pattern offers better testability than inheritance. If we use this pattern with dependency injection, in our tests we can easily use mocked objects. Third, by using the delegation pattern we'll have more decoupled codes than using inheritance. When using inheritance, we may end up with a deep class hierarchy, and making a change in a superclass may destroy its subclass's functionalities. And fourth, the delegation pattern makes our code more flexible. It means we can easily replace the implementation of the composed classes with other versions. Now that we know the benefits of the delegation pattern, here's an example. Imagine we want to create a car class with two functions. One of its functions is a start and the other one is turn. This class will delegate the responsibilities of its start function to an instance of the engine class, and it delegates the responsibilities of its turn function to an instance of the string wheel class. So for the engine, I'll create a new interface named iEngine. This interface has a function named start. Also for the string wheel, I'll create another interface named iStringWheel. This interface has a function named turn. Now I want to create the engine class, so I'll create a new class named engine and implement iEngine in it. And also I override its function. In the start function, I'll print a message. For example, engine-start. Also, I'll create another class named stringWheel. This class implements iStringWheel interface and overrides its function. In the turn function, I'll print a message, for example, st-turn. Until now, we have two classes and two interfaces. Now everything is ready to create our car class. So I'll create another new class named car. This class must implement both iEngine and iStringWheel interfaces. So I'll write iEngine and iStringWheel, and then I overwrite their functions. Because this class wants to delegate the responsibility of the start function to an instance of the engine class, and it wants to delegate the responsibility of the turn function to an instance of the string wheel class, it takes an instance of the engine class and string wheel classes. So on its constructor, I write private val engine with type iEngine and private val string wheel with type iStringWheel. Now here in the start function, I write engine.start, and in the turn function, I write stringwheel.turn. Until now, we could create a car class using the delegation design pattern. It is very simple, isn't it? Now let's write some codes and test our project. So I'll create an instance of our car. For its first parameter, I'll pass an instance of the engine class, and for its second parameter, I'll pass an instance of the string wheel class. Now we can call its functions and see the result. Here, because we are delegating the responsibility of the start function to an instance of the engine class, it prints engine-start. And here, because we are delegating the responsibility of the turn function to an instance of the string wheel class, it prints st-turn. This is all for the delegation design pattern, and we could create a class using this design pattern. But because Kotlin natively supports this design pattern, we can remove all of these codes, and here after the iEngine, we must write by and write engine. And also after the iString wheel, we must write by and string wheel. Now if we run the project, we'll get the same result as before. But the other thing I want to mention is that we can override the functions. For example, if we like, we can override the start function and print another message. For example, car-start. Now if we run the project, instead of printing engine-start, it prints car-start. This is all for this topic, and I hope you enjoyed it. If you have any suggestions or if you need further help, please send me your comments.